Hello everyone, this is Pankaj and I welcome you all to New Day, New Question series. And once again, I have brought you one more question as you can see on the screen. The question is basically saying the space between two concentric spheres of radii A and B, where of course B is greater than A, is filled with a medium of resistivity rho. Okay, the resistance between the two spheres we want to find. Okay, so let's try to understand the question. Basically we have two concentric sphere. This is the one, this is the second one. Radius of first one is A, radius of second one is B. We have material which is being like inserted in between these two spheres and we want to find the resistance of this material. Resistivity they have given for this material as a rho. So as we know that when we will move from A to B, when we will move from A to B, our radius is continuously changing. So we cannot basically directly find the resistance. We will have to go with the concept of integration. Okay, so two key concepts we are going to use here. So let me write two key concepts. So first key concept which we are going to use is basically the formula for resistance. R is equals to rho L by A. So we are going to cut one small sphere from this big sphere, and for that small sphere we will find the small resistance and then we will integrate it. And the second key concept which we are going to use is basically the concept of integration, which I have already explained. Okay, so these two concepts we are going to use. Okay, let's cut the small sphere from here. So this is the small sphere which I'm going to cut, and of course I will take its radius also. So let's take the radius of this small sphere as x, which will continuously change from A to B. And one more thing, thickness of this small sphere. So the thickness of this small sphere I'm going to take as basically dx. Okay, so for understanding purpose I'm drawing this sphere separately so you can see clearly basically how it will look. So this is the small sphere which we have cut from that big sphere. Its radius, how much we set? Its radius is basically x, and thickness we have set like its thickness is basically dx. Okay, now let's apply the formula. This sphere will be hollow sphere. So for this hollow sphere our small resistance will be basically dr, which will be equals to rho. Its length is basically dx and its area, as it is a sphere, so 4 into pi into radius is x, so 4 pi x square. But we wanted to find the resistance for the complete that concentric sphere. So for that we will have to use the concept of integration, and that's why I will integrate both sides. So on left hand side resistance will be from 0 to capital R, and in order to completely cover this concentric sphere we will take lower limit as a radius A, upper limit as a radius B. Okay, so integration of dr will be basically R, rho is constant term, then 4 pi is again constant. Now we want to integrate basically this dx upon x to the power 2, limit is from A to B. Okay, now rho upon 4 pi integration from A to B, x will become x to the power minus 2 dx. Now after applying the concept of integration, r is equals to rho upon 4 pi. So integration of x to the power minus 2 will become x to the power minus 1 upon minus 1, and limits are from A to B. Okay, one more step which I am going to increase here is I am going to take this minus sign outside, like here I have written that and I'm going to take x to the power minus 1 into the denominator. It will become simple x. Now after this step we can put the limit, lower limit a, upper limit b. So final value of resistance will be minus rho upon 4 pi. It will be 1 by b minus 1 by a, and at last after sending this minus sign inside, r will be equals to rho upon 4 pi 1 upon a minus 1 upon b. This is the value of resistance which they have asked us in the question. So which two concepts we have used here? First, concept of basically formula of resistance in terms of resistivity, and second, formula concept of integration.